Hello students, welcome back. This mini lesson is going to be focused on the concepts of distance and displacement. Okay, as we've previously discussed, distance is the total distance traveled, and displacement is how far something is from where it started. Okay, so I've written out my descriptions of each one of these here. You may remember from the last class that we referred to variables that do not depend on direction we call scalars. So in this case, distance is the scalar because it doesn't matter if I'm going forward or backward. Either way, I'm traveling that amount of distance. Okay, and on the other hand, displacement does care about direction, so we call these variables vectors. So we've already applied these concepts to examples where someone or something is moving forward and backward in a straight line. That is, of course, the focus of this unit, one-dimensional kinematics. I went ahead and looked at the test to see if I had to teach anything else about these concepts, and there is one thing I have to touch on today that actually doesn't involve one-dimensional motion. But let's look at a different type of example where someone makes a turn. Someone walking to a street corner and then turning right on that street corner to follow the sidewalk of the adjacent road. That person would approach the corner of the street, and then once they get to the corner, they would make a 90-degree turn. In this case, we aren't truly in one dimension anymore because we're no longer traveling in just a straight line. If I wanted to calculate the distance traveled by this person and also the displacement of the person, I'm going to have to think a little bit harder about how to get the answer. Specifically whenever I'm calculating displacement. For distance, it doesn't really care about direction, so the fact that we're in 2 dimensions now doesn't matter. I would just add up the distance traveled total. So if I initially traveled the distance of 7 meters, and then turned right, and then traveled the distance of 5 meters, then my total distance traveled would just be 7 plus 5 meters, which is 12 meters. On the other hand, though, displacement does care about direction. So this is going to change the way I do my math, and I'm trying to find out how far is this person from where he started after he does this turn. If I'm trying to find displacement in this example, I'm trying to find this distance right here. In this case, it's the hypotenuse of this right triangle. You might have learned in geometry class or a previous math class, if you have 2 side lengths of a right triangle, you can calculate the third missing side length using the Pythagorean theorem. Just to refresh you guys on what the Pythagorean theorem says, if I have a right triangle with side lengths A, B, and C, where C is the longest leg of the triangle, which is also called the hypotenuse of the triangle, I can relate these 3 side lengths with this equation. Okay, so A squared plus B squared is equal to C squared. This is the Pythagorean theorem, and this is what we're going to apply to this example so that we can find the displacement. If I say that this leg is my A, and this is my B, and I need to find C, then I can plug in these numbers into this equation to try to find C. So I'm going to do that now. Okay, so I've plugged in my numbers for these 2 sides of the triangle into A and B for the Pythagorean theorem. And this is what I have. I have 7 squared plus 5 squared is equal to C squared. If I do that math and crunch those numbers, I'm going to have 7 squared is 49, and 5 squared is 25, and that's all equal to C squared. Then next, I would have to add those 2 numbers. 49 plus 25 is 74. And then the last step I would have to do would be to take the square root of 74, because I don't care what C squared is, I care what C is. So if I want to get rid of this square that's on C, I'm going to do the opposite operation of what's happening to it. So the opposite of squaring something is to take the square root of something. So if I take the square root of both sides of that equation, I can find my answer. Okay, so when I take the square roots of C squared, the square root is going to cancel with the square term. Okay, so I could scratch out the square and the square root, and I'm just left with C is equal to the square root of 74. So I'm going to use my calculator to take the square root of 74. That comes out to approximately 8.6. Okay, so using the Pythagorean theorem, I was able to find how far this person ended up from where he started. In other words, this leg of the triangle. In this case, it came out to 8.6 meters. One extra thing to note is that since displacement cares about direction, it is a vector after all, it's important to indicate where the object is displaced. Is it displaced that way? Is it displaced that way? You don't know unless you actually clarify. So instead of just saying 8.6 meters is my displacement, I'm going to be more specific and say that this person was displaced 8.6 meters in the northeast direction. So there I have a more complete understanding of where this person ended up. And just to compare that to the other side, when we're talking about distance, where it doesn't care about direction, I don't have to include any information of where the person is after how far he walked. Distance is simply measurement of how far that guy's little legs moves. So now you've seen how displacement and distance can be applied to examples of something just moving straight forward and backward in a line, and also in examples where things turn at right angles. And both applying the concepts in both those ways is important to know for the test, so that's why I'm covering it. Although the focus of the unit will return back to just being in one dimension, just going back and forth in a line. I just wanted to make sure I touched this triangle stuff right now while we're talking about distance and displacement. We'll continue to practice with this stuff and get used to the math that is involved. I encourage you to ask plenty of questions. All of us come from different backgrounds in math, so it's okay to struggle a little bit, especially with things like this, solving the Pythagorean theorem and knowing how to plug in numbers and then do the proper operations to find the answer. It just takes practice, so just have patience and keep on at it, and then you'll get it. Thank you all. I hope this video helps you understand this stuff a little bit more. See you next time.